Dear students, welcome to the problem solving session on exponential distribution part 2. In the previous video, we saw the definition of exponential distribution. Suppose lambda is a parameter which is greater than 0 and x greater than or equal to 0, then we write f of x is equal to lambda into e power minus lambda x. If the condition violates, then f of x is equal to 0. And then we see memoryless property of exponential distribution. Suppose s and t are any real numbers greater than 0, then probability of x greater than s plus t provided x greater than s is equal to probability of x greater than t. And we see the proof of this memoryless property. Sometime in exams they will ask you the question, state and prove memoryless property of exponential distribution and hence solve some given conditions. So you have to prove this property, and using this property we have to solve the problem. And then we solved a simple problem on exponential distribution. And in today's session, we are going to solve one more problem on exponential distribution. And finally, we are going to compare all the 4 distributions which we studied in this unit. That is binomial, Poisson, normal distribution and exponential distribution in a nutshell. Now let us go into the problem. The time between 2 successive customers arriving at a bank follows exponential distribution with the mean 5 minutes. So in exponential distribution, the mean is 1 by lambda. So 1 by lambda is 5. So lambda equal to 1 by 5. At first we write x follows exponential distribution. So my f of x is lambda into e power minus lambda x, where lambda is equal to 1 by 5. So substituting this, we get f of x is equal to 1 by 5 e power minus 1 by 5 into x. Next, we are going to solve the problem one by one. Now, it is a very important step. In the previous video, I just give the idea how to solve the problem. But in the exam point of view, it is very essential. We have to derive this. Then only we can use the content as the formula. If you write the formula directly, you will lose the marks. So, for a part B question, it is very important you derive this initially and consider this as equation 1. Then, for each part of the problem, we recall equation 1. From 1, we can solve the problem very easily. So, first let us find probability of x greater than t. So, we know the formula integral t to infinity f of x dx. Just now we found f of x. We don't want to substitute the value. We just keep the content as simply lambda. So integral t to infinity lambda into e power minus lambda x dx. We'll take the lambda out, and integration of e power minus lambda x is e power minus lambda x by minus lambda. The lower limit is t and the upper limit is infinity. Now we can cancel this lambda and then we keep the minus outside. Substituting the upper limit, we get e power minus infinity minus e power minus lambda t. And we know that e power infinity is infinity. Therefore, e power minus infinity is 0. So substituting here, we get minus of 0 minus e power minus lambda t. So minus into minus plus. So we get e power minus lambda t. So we have to derive this. It is very important. Once we derive this, we can use this result for all our problems. Now let us go into the problem. Now let us see the first question. What is the probability that time between 2 successive customers are more than 8 minutes? Then second one is very easy. Probability of x less than 3 minutes. The third one is probability of x lies between 2 to 6 minutes. And finally, the last question is, what is the probability that x is greater than 10 minutes given that already 5 minutes are elapsed? So we can use memoryless property for the fourth question. Let us solve one by one. We have already derived that probability of x greater than t is equal to e power minus lambda t. So now we have to refer from equation 1 that probability of x greater than 8 is e power minus lambda 8. Also, we know the value of lambda, that is 1 by 5. So we get e power minus 8 by 5. Now you take your calculator and easily find the value of e power minus 1.6, that is 0.2019. Next, for the second question, probability of x less than 3, I don't have any formula. I have a formula x greater than t. So I can rewrite this as 1 minus probability of x greater than or equal to 3. And the distribution we choose is exponential distribution. It is continuous. In continuous distribution, we know probability of x greater than or equal to a is always equal to probability of x greater than, because we know the result, probability at a particular point a in continuous distribution is always 0. Therefore, 1 minus probability of x greater than or equal to 3, I can write it as x greater than 3. Using equation 1, we can write this as 1 minus e power minus lambda into 3. Lambda value is 1 by 5. So 1 minus e power minus 3 by 5 will give you the answer. You can use the calculator and verify the solution. So the answer is 0.4512. Now let us solve the third part. What is the probability of x lies between 2 to 6? Let us have the visualization. We'll mark the 2 points. Now the region which we need is 2 to 6. But the formula which we derived is probability of x greater than some t. So how to write this? First we think x greater than 2. If it is x greater than 2, it goes up to infinity. Similarly, x greater than 6 means from 6 it goes up to infinity. So, if you take probability of x greater than 2 and probability of x greater than 6, if you subtract this green region with yellow region, we get the required red region. Therefore, probability of x lies between 2 to 6 is probability of x greater than 2 minus probability of x greater than 6. Now, using equation 1, I can rewrite this as e power minus lambda into 2 minus e power minus lambda into 6. We know the value of lambda is 1 by 5. So e power minus 2 by 5 minus e power minus 6 by 5. Using your calculator, you can find the value and the final answer is 0.3691. And we have the final problem. For this, we are going to use memoryless property. Probability of x greater than 10 provided already x greater than 5. Now, we have to rewrite this 10 like x greater than 5 plus 5. That means in terms of 5 plus remaining values. Now, by memoryless property, I can leave this both and I can write this as x greater than 5. Hope you understand, students. Now, using equation 1, it is e power minus lambda into 5 and lambda value is 1 by 5. So both will get cancelled. In your calculator, you have to find e power minus 1 and the value is 0.3679. So now, what is the important point we see in this problem? Whenever we solve problem for exponential distribution, it is very important we have to derive probability of x greater than t is e power minus lambda t and take this as equation 1, and then we can easily answer the questions given in the problem. Now let us see the comparison between the 4 distribution which we studied in this unit. First take binomial, Poisson, normal and finally exponential distribution. Range of x. In binomial distribution, x lies between 0 to n, it is finite. In Poisson, it goes up to infinity from 0. In normals, we say x lies between minus infinity to infinity. In exponential distribution, x should be greater than or equal to 0. And then we can see the formula for binomial, Poisson, normal and exponential distribution. And we know that Poisson and binomial distribution are discrete. Normal and exponential are continuous distributions. Mean of binomial distribution is NP. For Poisson distribution, the mean is lambda, that is equal to NP. In normal distribution, the mean is going to be mu. And in exponential distribution, it is 1 by lambda. Variance of binomial distribution is NPQ. For Poisson distribution, the variance is also lambda. For normal distribution, the variance is sigma square, and for exponential distribution it is 1 by lambda square. Next, binomial distribution depends on n and p, so it is called as biparametric distribution. But Poisson distribution depends only on lambda, so it is uniparametric distribution. Similarly, normal distribution depends on mu and sigma square, so it is also biparametric. In exponential distribution it depends only on lambda, so it is uniparametric. And similarly, we can see the moment generating function that we are going to see in the next video. And finally, what are all the properties we have? Binomial, mean is always greater than variance. In Poisson, mean is equal to variance. In normal distribution, the curve is symmetric. And in exponential distribution, we have memoryless property. Hope this table will give the clear idea about all the 4 distributions which are all available in the syllabus. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.